So audible to the last benches? Yeah. I'm doing this for the first time, so if I do that, this, please wave your hand and we can get started now. Alright. Anyone has any experience in IoT app building so far in Flutter or any native platforms? Probably web as well. Yeah, one person? Yeah, good. So you may know about IoT a bit, some parts and all those things, I assume. Yeah. What is the full form? If you could, tell me, and some definitions of IoT, if you could tell me. IoT, what is IoT, and where is it used actually? IoT is Internet of Things. In which we can code and get the machine work according to our code, so it will be functioning IoT. Alright. Any other definitions? Okay. So, yeah. Basically, I'm trying to cover this presentation as a mobile app developer, what you should be taking care of while you're working with the mobile application in IoT, specifically in Flutter. The 2 or 3 sections on the top is more or less without Flutter. You will just get the concept of IoT first, a basic idea, and later on we'll dive into a Flutter side of things, and then we'll move forward with the, some block patterns that we could figure out. You can also take advantage of that. Next. So yeah, first part, IoT what? Yeah. So as gentleman said, it's Internet of Things. It's the network of devices. When you say a network, it could be a remote or a local as well. Local means you connect with the Wi-Fi hotspot and all those things, BLE. So that is also a network of devices. This device is actually collecting the data in the real world. So you install the device such as a smartwatch on your wrist. It collects your health data and it gets saved somewhere in the server. Probably it gets shared with the mobile application. We don't know how Apple Watch works, but probably this is the technology behind it. We can call it an IoT device. Another could be a smart home devices, a cleaner that you will know where exactly it's in which room at your home, and based on that, mobile application is showing you what is it doing, how is it doing, what is the status, and all those things. So those are called then IoT devices. So Internet of Things, it's a network, it collects and shares the data. Next. There are components which makes any hardware as an IoT device. So there are 3 components that I could figure out. It could be, anyone can debate on that, but these are the, based on my findings and based on the research that we did at Origin. First of all, I'll help you. Recently we worked on a location. Thank you. Yeah. So there are 3 components. One is device, second is software, firmware, and the third one is the network. A device should have a firmware which will be able to process the data, manipulate the hardware, get the data out of the hardware. For example, if there is a GPS hardware on the device, you will be able to collect the data. So that software, the firmware on the device will do the things. The network should be there because without the network, you cannot send out the data. Now, these devices are actually installed in a very remote location. So a network connectivity should be there, but with the very limitations. Without the internet or without the network, it does not make sense to have a IoT device, around you, because if it does not share anything from the device, it may not be able to do much for you. Since it's the smart devices, you can also tell them it's supposed to work. So these are the 3 components, and the next slide is the how part. How would you create an application as a mobile app developer? What part you need to figure out? First of all, when you say figure out, Basically, you would want to have a workflow on your application, and anything you need to do as a mobile app developer, where you'll have to figure some technical parts around it. So this is the how part that I'm going to cover. First, we'll see a basic thing, a basic workflow, how IoT entire system will work. So there are 4 steps. You can please check that out first. Last people, last benches, do you see these slides in the bottom? Okay, good. So the first step is the collecting the data. As I mentioned, it should collect the data. Without the collection, it does not make sense. Then it's supposed to share the data. We can use some network, internet, MQTT protocol is one of them. And then there is a process. If you can't process the data, you will not be able to show them on the UI. If you are not able to show them on the UI, that it does not make sense. What would end user get? So that is the processing, and then there is a show data. So with the processing of the data, you'll get the data on the mobile application, admin panels, web application. It could not be one mobile application; it could be multiples as well. There could be a web app which will manage and admin the data, and then there is a other interface. But why do we need a mobile application in IoT? Well, it's not mandatory to have a mobile application, but it's all about convenience. When you find your users are not using the application much, then means it's not convenient for them to use the device and get the data out. That's why the interface is needed, and that's why mobile application is quite handy compared to other interfaces. No one would want to go onto the web application and log in and then check the data. If I'm tracking my pet somewhere in the mobile application, it's very convenient. I'll have other features as well. I'll have my location to be shared somewhere. Feature design could be enhanced. So that's why application is more prominent. Mobile application is more prominent in the IoT field. Next. So the earlier slide was the basic workflow. This one is a bigger picture. What 3 things that you need to figure out first to just talk with the client? Okay, this is how we are going to build. And as a mobile app developer, you will be focused on the mobile side, but it's always good to have some basic idea what's happening behind the scene, right? So there is a cloud and there is a backend. You need to finalize the cloud provider first. Without the provider, you cannot basically collect the data. You'll have to run your own servers if you are not going with the providers. Then there is a second IoT device. When you say IoT device, it's actually the first slide that we explained. It's an actual IoT device. You need to register to the backend and basically a cloud provider. And then there is a third part. It's our mobile application. Yeah, client. Uh, Web client, mobile client, any client. Desktop application could be a client as well. So a client. So these are the 3 basic components. When you want to figure it out, every stage will require you to figure out something. Cloud provider is needed. I'll come on to that, why it's needed. Then there is a backend. You need to figure out what data, where it will be saved. So database and all those things to be finalized as well. So as a mobile app developer, your team should have a backend developer, cloud ops developer as well, if available. Otherwise, backend developer can make sense, to complete the work. IoT device is usually a client that comes up with. In the service-based company like ours, client comes up with the firmware and all those things. You don't have to worry about it. You just need to understand that what it will, share to the mobile application. How part is something that we need to provide a solution for. Then there is a client. So client can either be same. We'll have to figure out the mobile application as a mobile devs and what plugins that you should be using, what things that you need to take care of, slide, some edge cases and all those things. So as I mentioned, we need to finalize the cloud provider. In AWS IoT Core is the cloud, it's a managed service from the AWS. The reason why we are finalizing the provider is because to make the system work, to make the device communicate with the backend system, it will require some sort of protocol finalization. It will require some infrastructure to connect with. So that is where the cloud provider would come handy. But you may ask why we are not going custom. Usually we use the AWS cloud provider for a very specific reason. It provides us a managed service, right? It provides with the basic, instant EC2 instance, a storage space. You just need to spin up, and that's it. So similarly, for IoT to work, it's providing you a very good managed services. So, sorry. So this is the basic diagram how the MQTT protocol will work. I'll explain the details, but you can just assume that there is a user who is going to publish the data to the cloud provider. You don't have to worry about whether which data will be passed on to which device. It will be figured out later on by the cloud provider and by the IoT managed services. Then there are devices, you see. So these devices are going to get connected with the AWS IoT core and not directly with the client. So it's not client server kind of client to client communication. It's actually client server like workflow, very basic HTTP workflow that we follow. Yeah. MQTT. So these lines that you saw earlier slide, it's actually a path to send out the data and get the data. Now you may ask why there is a different protocol in the market. Well, anyone had any idea why we are using MQTT and not the HTTPS? Because we have as a mobile app developer, everyone would have done at least one REST API call, right? One API call is needed, and everyone would have done that. Then why we are not using the ready-made HTTP, very mature protocol, instead of why we are going with the MQTT protocol? Anyone can answer? IoT people. Hmm. Okay. Yeah, right answer. So, sorry, you'll have to skip it. Yeah. So there is a messaging queuing telemetry. It's a full form. You don't have to worry about why it's like that. It does not make sense to me, to be honest. But he said right. It's a lightweight protocol. It works on the publisher subscribing manner. Publishing means you publish to the data on a very specific topic, and then you forget about it. Whether the other people had read about it, it's not your job to identify that. Where in HTTPS, when you are requesting some resource from the server, you'll be kind of doing an API connection, you will be doing a socket connection to, and then you'll wait for the response. Until and unless you get the response, you'll not be coming back. So usually it's like 1 second or 2 seconds of threshold, in milliseconds as well. But there is a timeout, there is a response, but then there is an error. These are the three possibilities for the HTTPS connection. So you'll have to wait and then watch what's coming back. Where in MQTT you don't have to do that. You just publish your data, whatever device is collecting, it will be publishing to a cloud provider, to the IoT managed services. And that's it. It doesn't need to know which client has consumed my data, which mobile application user has consumed the data. It will be figured out and architectured in a way where data would be distributed. So next, yeah. There are other protocols. I'm not the expert on that protocol, so I cannot comment on that. But there are other special cases in the IoT field. It does not need to be only MQTT protocol. There are other cases where MQTT may not be viable solution. But the other thing is that if you use your common sense and understand that this device is usually is on the very remote places. Uh, for example, you are monitoring a soil and you would want to collect the data. Well, soil usually is by the farmer. You will go to the land and make your test and everything else. But usually it's in the remote place. You can't rely an active internet connection over there, and that's why It's a lightweight. It's supposed to be lightweight. That's why it's used compared to HTTPS. Yeah, next. Yeah, okay. So these are the topic string. You can assume that any topic, it's like a Firebase. Anyone have used this Firebase topic-based push notifications? Yeah, it's very similar. You'll just have to write your string over there. You'll be publishing or subscribing. That's it. Similarly, MQTT works in the same manner. It's a PubSub protocol ultimately, and Firebase push notification for that topic-based system is using similar concept over there as well. Now you'll see that there is a broker in between these parties. Admin console, again a client, data processing is a backend, probably a client to a broker, and then there are devices on the left. So device will publish to data to a broker. Broker will pass on the data to different clients. Whoever is subscribed to a specific topic, it will get passed on. Now this broker is supposed to be a server. Now protocol has to work, right? Protocol requires some server. HTTP requires a specific dedicated server as well. So MQTT does need that. Now, if you see, this entire thing has to be managed by you. If you are going solo, if you are not using a managed services, if you are not using AWS provider, cloud providers. That's why IoT, AWS IoT core is there for us to, use it. So you don't have to worry about this infrastructure, and you will focus mainly on solving the problem. Yeah. Now the main thing, everyone here is I guess, Flutter dev, right? In Flutter, whenever you want to do a REST API connection, what you'll do? What libraries would you be using? What plugins would you be using? Yeah, it's called a client, right? HTTP client. Similarly, in MQTT, it's a protocol. You'll require a client to make a connection to the server and to make sense out of it, to get the response actually from the server. So in Flutter, there is a plugin called MQTT client. There are other plugins as well, as Flutter has more than one plugins for each problem. But this one is quite good. It has a very good ratings as well, WeChat. And so there is a client. You need to create a client. You need to subscribe to a topic, and you will listen for the updates. So this is the basic three operations that you will want to do on the mobile application. There is a publishing as well, but mostly when you are reading the data, device data, you would want to do these three operations also. So to make the connection, you write the client, you create the instance of the client. Then there is a subscribe. The topic name goes over there. As soon as a device, let's say, I'll clarify. Uh, so we talked about the pet tracking application, right? So that device had a one location topic. Now device would publish to a data on very specific topic, which is called a location. So you'll have to write a location topic name over there. Whatever data is published into that topic, and you would want to listen for the updates, you'll have to write that topic. Then there is a updates. As soon as the new data is available on that topic, you'll get the callback. That's it. It's as simple as that. In HTTPS, it's reverse, right? You'll have to wait for the response. But in MQTT, you'll just get the callback as soon as the data is there for you to consume. So this is the last slide, by the way, and it's an opinionated version that we tried, and it worked very well at Abaji. Uh, so, and we are pretty much aligned with the block state management. I know it's debatable point, but that is what we are using. We tend to scale the application in a way where block helps us to do that. So we created an instance, we created one block for MQTT. Now usually block will connect with the repository, and repository will do the HTTP connections, right? All the request response thing. In case of an MQTT, we just remove the repository because Again, it's an async structure that we are dealing with. When you call an async structure, that means you'll have to get the data, you can't wait for the response because it can be coming in any time. As soon as the new location data is available, device will send out to the client. Now, MQTT block will directly communicate with the API service. In our case, it's an MQTT service. MQTT will maintain all the connections. It will expose few basic functions like connect, disconnect, subscribe, publish, and the updates as well. Block will communicate with the service, make sure everything is done. You send out one event to connect, then you send out another event to read the data or publish and subscribe the data. And as soon as the updates are coming into the block will send out one event and emit the states. A state would be very generic state. A new data has received. You can assume that. It will have the topic, name, and the data along with that. Whoever wants to listen for a location update, any screen A, screen B, screen C, you just need to listen for the state stream from the block, from the other blocks, and your UI will be updated. So this is a very simplified pattern that we tried, and it's working well. There are other edge cases as well. When your application in the background, you are supposed to either read the data, save it, or you are supposed to disconnect it. Based on the device requirement, based on your client's requirement, we'll have to figure that out actually. So we had a very simplified requirements. You just disconnect the client as soon as you are going into the background. So we did that with the callbacks and all those things. So you can figure that out on your own by asking the questions to the client. So yeah, I think that covers these entire thing for a blog, and I'm also done. Thank you.